Welcome to The Explainer. Today, we're diving into a really fundamental idea in statistics, understanding the spread of data. It's what gives numbers their actual, real-world meaning and helps us move way beyond just looking at a simple average.
We use averages all the time, right? But when do they actually fall short? When do they fail to tell the whole story? Let's jump into an example that shows you just how misleading a simple average can be.
Okay, so take a look at these two cities. On paper, they seem exactly the same. Both have this really pleasant average temperature of 15 degrees Celsius. But then you look at the daily temps. City A is super stable, really consistent. City B, on the other hand, is a total roller coaster. You'd have to pack a winter coat and a swimsuit for the same week. This shows perfectly why an average all by itself can be so deceptive.
And that really gets to the heart of the problem here. The average, or the mean if you want to be technical, it tells us where the center of our data is. It's a single point of reference, but it tells us absolutely nothing about the variety, the swings, the actual experience happening around that center point.
So if we want to tell the full story, if we really want to get what the data is saying, we're going to need another tool. And in the world of statistics, that amazing tool is called the measure of spread.
So here's the formal definition. Spread, which is also sometimes called dispersion, is really all about describing how varied your data is. Honestly, you can think of it as a way to measure the data's personality. Is it kind of consistent and predictable, or is it wild and just all over the place?
All right, let's start with the simplest measure of spread you could possibly calculate, the range. We'll see how it works, and maybe more importantly, where it has some pretty big limitations.
Calculating the range could not be easier. You just find the two extremes in your dataset, the biggest value and the smallest value, and then you just find the distance between them. That's it. It tells you the full span of your data from end to end.
And right away, this shows the huge difference between our cities. City A has a tiny range, just 4 degrees. City B, a massive 40-degree range. Simple. But this also shows the range's biggest weakness. What if City B just had one single freakishly cold day, a total outlier? The range would still be huge, making the whole week look extreme, even if all the other days were pleasant. It's just so sensitive to those extremes.
So to get around that problem, statisticians have a much more robust measure called the Interquartile Range, or IQR. Imagine you line up all your data points from smallest to biggest. Then you just chop off the bottom 25% and chop off the top 25%. The IQR is just the range of that middle 50% that's left over. This gives us a much more stable picture because it completely ignores those wild outlier values.
But if you want the most complete, the most powerful picture of spread, you need to look at what's really considered the gold standard: variance, and its close cousin, standard deviation.
And this quote from our source material really captures why we even need these tools. It's not just about crunching numbers. It's about figuring out the true nature of our data, about seeing the hidden relationships between different things.
Okay, so this starts with something called variance. But to make that number way more intuitive, we take its square root, and that gives us the standard deviation. And put really simply, it just answers one critical question. On average, how far away is each data point from the center? It's not the total span like the range, it's the typical distance from that average.
So if you calculate a low standard deviation, it means your data points are all huddled together, clustered nice and tightly around that average value. Your data is consistent, it's predictable, there's very little variation, just like our nice calm City A.
And on the flip side, a high standard deviation tells you the exact opposite story. The data points are spread far and wide. They're scattered all over a huge range of values. This tells you the data is volatile, it's way less predictable, and far from the average, which is, you guessed it, the perfect description for City B. All right, let's bring it all back home. We're going back to our two cities one last time to see how this one number, the standard deviation, finally tells the whole story and clears up all the confusion. For temperate City A, the standard deviation is a really low 2 degrees Celsius, and that number confirms exactly what we saw with our own eyes. The daily temperature barely moves away from the average. It is incredibly stable, day in and day out.
And then we have volatile City B. Its standard deviation is a whopping 20 degrees Celsius. That's 10 times bigger. The single number perfectly captures its wild temperature swings and its totally unpredictable climate.
And this slide just puts it all together so perfectly. Look at that top row. The mean temperature is identical. If you stop there, you'd be totally misled. But then, as you move down through the range, and especially to the standard deviation, the real story just jumps off the page.
These numbers tell us with mathematical certainty which city has a calm climate and which one is a climate of extremes. So what's the big takeaway here? It's this. The average gives you a single fact, but the spread reveals the data's character. It adds that crucial context, helping you understand the reality behind the numbers so you can go on to make much, much smarter decisions.
And that is our explainer on statistical spread. So the next time you see an average reported somewhere, remember to ask, yeah, but what's the spread? Because the average only gives you a quick snapshot, but the spread, that's where you'll always find the real story. So, what stories are hidden in the data all around you?